In the last interview, we had a beautiful conversation with Mr. Sanket Hudar sir regarding small satellites and their growth. Today, we are going to talk about an important technology or a part which is used in the small satellites, that is the antennas. The speaker we have today has been working on advanced antennas for small satellites which will enable them to send or receive data easily. They aim to send small satellites in higher orbits and also use them for deep space applications. Hi guys, I Prasad Doke on the behalf of AstroCapsule welcome you all again to the next episode of the Aerospace and Aviation Show. And today we'll be talking with Mr. Mayank, who is working as the co-founder of Celestial Technologies in Germany. Giving a short introduction about Mr. Mayank, he has completed his masters in Berlin and now he is studying as a PhD student in Finland. So be with us till the end and listen to this beautiful conversation on small satellite with Mr. Mayank.
Mayank sir, welcome to the Aerospace and the Aviation Show. And so we'll directly skip on to questions. And my first question to you would be the Celestial Space Technologies. It is a big part of your life and it's also growing very rapidly. What would you like to tell about it?
Yeah, sure. Thank you for the question. And maybe I just also give a few words about myself before I explain about Celestial. So I am currently in Finland, and I'm pursuing PhD over here in space department. I completed my master's in space engineering from Berlin, and I'm one of the founders of Celestial. And Celestial is a new space startup. We are working on new or advanced antennas for small satellites at the moment, but we have a vision to enable small satellite missions for higher orbits and deep space applications, enabling lunar economy or moon missions with small satellites. So that's what Celestial is all about.
We are manufacturing satellites. So would you like to explain us means what role do satellite exactly play, how they are important?
Yeah, so we are not exactly manufacturing satellite, we are manufacturing systems. Not manufacturing actually, we design systems, we outsource our manufacturing. So we have a production line which is spread out in Europe, and we try to place an order with our suppliers and they manufacture it for us. But the real engineering or science behind how our system work is done by Celestial itself. In the future, we might start manufacturing our own satellites or even develop our own satellites, but that is something down the line, couple of years, I guess. And yeah, so that's where Celestial is there right now.
So as your expertise in antenna, you told, so how is it important to satellite? Means what is its role and how complicated is it? Because if we see an antenna from outside, we just can see a metal rod, but I know in inside it would be having many different things.
Yeah, no, actually, antennas are in electronics language open circuits. All the current that flow through antenna is radiated into the space basically. Uh, but there are many type of antennas, so they are quite important for any satellite mission, because based on the antenna, um, it is estimated or the mission planning is made, because you basically are able to understand what kind of systems you would need on the satellite. If your antenna can radiate in all direction, probably you don't need to control your satellite's directions and everything. But if your antenna is radiating into one particular direction, then you might need to control it when you're communicating to your ground station. So your satellite must point in one direction, right? So antennas are quite important part. Additionally, they are also so in very normal language, antennas have two principal tasks in a satellite mission, which is basically to direct the signal in a particular direction where you want or where the satellite developer wants it to, and secondly, to amplify the signal, to add strength to the signal. So they are also kind of passive amplifiers. Nowadays, we also have active antennas. So yeah, becoming more innovative as space industry is progressing.
So you also worked on constellations, means you have great knowledge in that. So what would you like to tell about the mega constellations we are having nowadays?
I think, yeah, mega constellations. I mean, I think they're revolutionizing space as well as terrestrial or any other field equally, and the communications. So they have a vision. Few of them to provide internet services to every part of the world, like SpaceX, for example, their Starlink constellation. And then there are others who are trying to do IoT services, or trying to explore different areas. Although all of this is having challenges, they're also having some kind of risks with space on the one side, but they're also providing and revolutionizing how I think the future is going to be. Probably there are going to be different services. For example, I know there is also studies and about a constellation that wants to provide GPS services inside the buildings. So right now we have this on the road, and they want to get into the buildings, for example. So there are very ambitious projects related to these constellations, and I think in next 10 years we will see something very different what we have now.
So as you are having a startup which highly works on antenna now, how important would be antennas in this project?
They're quite important, as I said. For any mission, antennas are very important. Plus, in these kind of constellations, you need more antennas because your satellites are often communicating to other satellites as well, and you are not just communicating to the ground. Additionally, you need high gain antennas, which means that you want to transfer much more data, so that you can cater your services to much more people out there. You also want this data or your signal to be distributed evenly, so that it shouldn't happen that somebody in North India is receiving weak strength and somebody in Central India receiving strong strength, and then South India again it weak, right? So everybody should have equal strength. So this is where radiation pattern of antennas become very critical, very important. And I am also aware that I think Starlink, they have next generation of satellites that they're developing. They're using active antennas, which mean you can control the radiation pattern of your antennas electronically. They're also very costly. They get heated up a lot, but this is also somewhere they are trying to go in the next iteration, I think.
Okay, you told about the radiation pattern. It how what is it?
An antenna is an open circuit, right? And
Right.
it basically radiates the current that flows through the circuit into the space, like electromagnetic waves. Okay.
Mhm.
So the form, or the way it is radiated out, is radiation pattern of the antenna. And generally, the antennas that you see on the Wi-Fi routers, like single monopole antennas like this, they basically radiate in all directions, like an apple, if you want to imagine.
Mhm.
Um, so this is one thing, and then there are other kind of antennas which radiate in a particular direction. Like you have this dish antennas for TV communications or multimedia communications, right? They're looking in one direction, and they
Mhm.
communicate only in one direction. So that's basically radiation patterns.
Okay, so as these communication satellites and constellations are increasing, how would you think are they gonna affect the common man's life?
Yeah. So as I said, I think next projects, they are going to be even much more on communications, and they will be providing services which today do not exist, like for example GPS services inside the buildings, or for example maritime services. So kind of a Google Maps, if you want to call it, for seaways, for airways, in-flight connectivities. So there are a lot of things that is happening with these kind of satellites now, and I think for a common man, especially India, which is already big on digital connectivity, I think things are going to be changing a lot in that way. A lot of services are coming up now.
So, as we know, space debris is something which has come up as a big problem nowadays. So, what do you think are the precautions or sustainability options being taken with the small and mega constellations?
So I'm so in space industry there is no particular hard and fast rules set up. The legislation is still missing. It's coming up, but it will take time. But generally, there is also something they say that a satellite should deorbit itself in 25 years. You know, this is a basic norm that is followed by most of the satellite developers at this time. People are also trying to get this years below now, lower than 10 years or so. But with mega constellations and now any other satellite which is going up, there is
Mhm.
always a risk of collision because now satellites are too much there. The orbits are congested. So I think orbit or mission planning and then satellite maneuvers in orbit, they are becoming very critical. A lot of services are coming which gives you in orbit warnings to protect your satellite from collision if or there is some warnings of possible collision and all of that. And there are also now propulsion systems that are there for small
Mhm.
satellites that help in deorbiting the satellite, or at least putting this satellite into the orbit where atmospheric drag is enough to bring this satellite down in next couple of years or so, whatever is the target. So I think people are aware of this and are worried about this, but the existing satellites which are already there, people are still trying to find solution. I am not aware of any particular solution which is confirmed and is working. But for example, European Space Agency is spending a lot on this. There is also companies in Switzerland, for example, they are working on this, but I'm not very aware of their principle and their mission actually.
So, sir, when we think of satellites, or when a normal person thinks of satellites, he just knows that it revolves around the Earth. But you have worked on a project in which you were able to control the altitude of the satellites. Explain that to us, please.
Yeah, so there are. I think I developed this system when I was in my bachelor's. So it's called momentum wheel. But there are many systems now in existence. So how this works is basically it's all about physics, and what happens is they basically any satellite which is using this antennas or has cameras, for example, they want to look at Earth and take photographs and want to have a particular orientation. So attitude of a satellite is orientation of the satellite, and then there is altitude of satellite. Altitude is with height. So this attitude of the satellite is sometimes needed to be controlled, and I think mostly it is needed to be controlled, mainly because you have a directional antenna which needs to point towards the ground station, and you have some kind of payload which is camera or something else that needs to observe the ground or take photographs or whatever. So you basically can use propulsion systems to control your attitude, that you want to direct your satellite in a particular direction like this, or you want to control your satellite using reaction wheels or momentum wheels. So you if you have a wheel inside the satellite, it rotates at a very high rotations per minute, and to compensate for this change in momentum inside the satellite starts rotating in the opposite direction. So if you put three on three axis, right, and then you can basically control these wheels and their movements, and then you can control the satellite in three directions basically. So that's how majorly this is controlled. There are two type of control systems: active and passive. The active ones are such as momentum wheel or propulsion systems that I explained. The passive ones are something that do not generate their own torques or force, but use the Earth's magnetism or magnetic field or gravitational force or gravitational field of Earth to basically control the satellite. But you cannot effectively control this in all directions. Your satellite is basically set; it is set. So if you have You would know this from your experiments in physics lab, that when you place a pin around a magnet, it takes particular direction, right? It is
Mhm.
oriented in particular direction. Similarly with satellite, you have a long tether coming out of your satellite, and with magnetic field, it gets fixed in a particular direction, and then that's it basically. Your
So
satellite is.
basically, we can say that the active ones are the temporary ones because carrying propulsion system or the fuel for long time is something which is a hard task.
No, but if you have momentum wheel, there are also electronic ones, and you have solar panels, right? So you can
Mm-hmm.
control it and you can generate power. Obviously, it is power intensive, it's
Mm-hmm.
difficult to manage and all, but they are much better in a lot of ways than.
Okay. Next question I have for you is Celestial Space Technologies is one of the 12 laureates of this year's Innovation Challenge at Paris Space Week. So can you tell us more about the prototypes and R&D R&D project you just presented there?
Yeah, so we are now, so we have three products in market already. And we have few first customers with us now. And at this time, we are developing a very innovative system where we are developing a new kind of antenna that will be integrated with other systems on the satellite. So because satellites are already very small, and because of this, we want to try and make volume utilization, mass utilization on these satellites more efficient. And so we are designing antennas that can be integrated to other systems like solar panels or cameras or any other payload. And this antennas would be able to then provide same kind of communication capabilities which our existing products provide, which is already three times better than all the other existing products or competitive products in the market. And this is the R&D that we are undertaking now. We are also part of a consortium which is developing a rover for the moon, and we are providing them these highly integrated antennas for them to actually use it on the rover for the moon, because this
Mhm.
technology is effectively made or is envisioned for such missions which are going in deep space and has low power on them.
Okay. You were also the finalist in Gravity Challenge. Tell us about that experience and what you did.
Yeah, in the gravity challenge, we were working with Lufthansa Technik. So
Mhm.
it's the airline company, but they also have different branches. So we were working with their technical branch to develop antennas, actually active antennas for aircrafts, where we could connect with this low Earth orbits and these mega constellation to provide internet capabilities and internet services to the in-flight en route passengers on these aircrafts, civil aircrafts. So that was a project that we took with them.
The moon is something which we have highly reached, and now we have reached the Mars too. So, how important do you think satellites and the new antennas technologies which are coming up will be helping in terms of deep space explorations?
I think, in my view, antennas need much more development. I think somehow antennas have been left behind in developments and innovations as far as space has evolved. And I think the existing antennas, they're good, they might even work, but there is definitely requirement for developing some very high powered antennas, and antennas which have minimum electronics on board and are able to give you best communication capabilities, and can work on small satellite architecture as well, because developing bigger satellite is not possible for everybody. So
Mhm.
if you want to explore space in a really nice way, I think small satellites have to be able to work on Moon, Mars, which right now is very challenging. Only NASA has done this once, but other than that, nobody is, I think, even working on this yet.
Okay, so it would be going to Mars means how would we explain that? Like not only Mars, the other planets or asteroids we can say, wherein we can say that such a long distance, it is even hard for satellites to cover. And sending a signal from there to here directly is a bit hard. So how do you think will that work out?
I think people are working on laser or optical communications as well. So
Mhm.
that is another way people are trying to get there. There are also projects on quantum communications. That is, I believe that is the fastest way of communicating right now because it would have zero lag even wherever you are in the universe probably. I don't know much about it, but there are a few R&Ds that are going on communication side. I believe, I don't know, maybe 10 years down, 5 years, 50 years, I don't know when they will be realized, but once they are in place, I think space exploration and communication through space would be much more easier than what we have now.
So you have worked in India and now you are settled up in Germany. So what is your take on the new space startups coming up in India?
Yeah, so I think in India, space is evolving very nicely. I'm not very well into the Indian space ecosystem yet. But how I perceive this is that they're mostly working on launch providers, which is very nice. I think India has very good historical background on this, reputation on this. So this is one thing. But also there are satellite developers. A few companies that I already know are working on constellations as well and developing their own satellites. So yeah, I think Indian space ecosystem or private ecosystem is coming up, and hopefully soon in next couple of years would also be an important part of the global space ecosystem. I hope.
So students from India, what should they know about the space startups or space system going on globally?
I think they should be aware of first of all the field that they are interested in and where this field is dominated. For example, not every country is working on launch providers, not every country is working on constellations, but every country is working on something or something else globally. So this is one thing I think they should be in conferences, follow these online events. Nowadays, it's very easy because everything is free online, right? You can be in an event or you're doing this podcast, for example, people can, I think, hear it. I don't think it's charged, right? I hope this is free.
No, it's free.
Yeah, exactly. So people can go around and there is a lot of material available and they can get to know a lot of things just sitting at home. I think if you dedicate 2 hours a week, you will be able to understand a lot of things about global space ecosystem.
Mhm.
Yeah.
So, a message you would like to give to this Indian students or the students around the globe, to whoever this is listening this.
Message. I don't know if I'm capable of providing a message. Um, I think, yeah, I think one thing that worked for me up until now is that I took risks and they worked out. Although if I go back now 4 or 5 years, I might not take those risks. They were painful risks. But at this time, I would say, yeah, take some risks, especially before 30.
Mhm.
Because if you fail before 30, the consequences are not that big. You can always change your course, and there are things. Yeah, you get lagged behind, you get delayed compared to your friends and fellows, but I see this as a growth as well, and I think there should be definitely few failures before 30s. So if people are not taking risk and they're ending up into a job, into a normal job, that is good, settled life and everything. But there is also a second part to life, which is failing and taking risk and all. And if you start taking risk late in 40s, 50s, then the consequences can be dangerous. So before 30, I think it's a good time to experience life that way.
Okay, to end with the interview, suggest a book and a movie for our listeners out there.
Okay, movie. I think I really like October Sky. It's a good movie.
Mhm.
Apollo 13 is a good movie. These two are motivating movies. And then book, I would say The Alchemist from Paulo Coelho. I think
Mhm.
it's a good book. I should read. Somebody should read it. Everybody should read it, in my view. It's a great book. Yeah.
Thank you, sir. It was great to have a conversation with you, and would like to have you in offline someday when we can sit and talk on more subjects. dive deep into the satellites technology. Yeah,
Yeah,
thank you
sure,
so
sure. Okay, yeah, thank you for having me, and thank you for the opportunity. I hope I was helpful. Thank you.
thank you, sir. It was a great interview.
Thank you.
That was an amazing conversation with Mr. Mayank regarding satellite antennas and entrepreneurship. To listen more such conversations, do follow AstroCapsule on YouTube, Instagram, and all other platforms. We'll be mentioning the link of everything below in the description box. And thank you for being with us.